Welcome everyone to Primetime Mathematics. Everyone forgets who I am, but my co-host this week is wrestling legend Jushin Thunder Liger. And today we're going to think about the concept of mutant derivatives. What are mutant derivatives? Well, they're like regular derivatives, but the x at the bottom of the notation symbol has been mutated. Now, what does such a mutation mean? And how do we actually evaluate a derivative of this form? It's actually quite simple, but let's go off on a slight tangent first. Let's say we have a cube with side S, and we're curious about the cube's volume and the cube's surface area. And we call the volume y and the surface area x. We know the formulas for the volume and surface area in terms of S, and it isn't hard to take their derivatives. And we can also take the ratio of the derivatives of the two, noticing that they simplify nicely to just dy over dx. This is the ratio of the change in volume to the change in surface area. And here's just a quick empirical verification that this ratio simplification technique seems to work when we have a cube with a side of 8. Now, getting back to our concept of mutant derivatives, what we did here was find the change in s cubed over the change in 6s squared. We didn't find the change in s cubed in terms of s. That would have been dy over ds, where y equals s cubed. Instead, we ended up taking the mutant derivative dy over d 6s squared, where y equals s cubed. That kind of gives us an idea of how mutant derivatives come into play. And we also saw how easy they were to compute. If we have a derivative like dy over d 6s squared of a function of y in terms of s, we take the derivative of both y in terms of s and 6s squared in terms of s and simply put them on top of each other. Nice. So now we're ready to take a derivative like this. We just imagine the bottom of the notation symbol to be a function, take its derivative in terms of x in this case, and put it underneath the normal derivative. And that is pretty much all we have to report on mutant derivatives here at Primetime Mathematics this week. Maybe at some point we'll find more useless mathematical ideas to report in the future.